Hello, this is video 4.4, proportional and non-proportional situations. So let's get started. Okay, today your objectives are going to be, I can distinguish between proportional and non-proportional situations using graphs, equations, and tables. And I can compare proportional and non-proportional situations. The standard is F2, compare properties of two functions, each represented in a different way, algebraically, graphically, numerically in tables, or by verbal descriptions. I'm going to minimize myself, and let's begin. Distinguishing between proportional or non-proportional graphs. Nonlinear graphs are always non-proportional. Nonlinear, non-lines, graphs that are not lines. So that is a non-proportional graph. It is not linear because it is not a straight line. It has a different slope going up and then the slope comes down. So it is non-linear and non-proportional. Linear graphs can be proportional or non-proportional. Okay, there's a linear graph that is proportional. Why is it proportional? It goes through 0, 0. Remember that linear graphs that are proportional will always go through the origin. This graph, however, is also linear but non-proportional. Why? Because it doesn't go through 0, 0, but it's still a line. This linear graph does not contain the origin, so the relationship is non-proportional. Linear or not linear? Proportional or not proportional? Okay, first of all, linear or non-linear? Correct, non-linear. That's what you should be saying. Right, non-linear. Proportional or non-proportional? Well, if it's not linear, it's automatically not proportional. So non-proportional. So it's non-linear, non-proportional. How about this graph? Linear or non-linear? Exactly, it is a line, so it is linear. Okay, proportional or non-proportional? It doesn't go through 0, 0, so it is non-proportional. Very good. Next one. The one below us, linear or non-linear? It's a little trickier, isn't it? Linear or non-linear? It's non-linear. Why? Because it's a V. The slope goes down and then the slope comes up. It's not a linear graph. Is it proportional or non-proportional? Well, if it's not linear, it's automatically non-proportional. Okay, next one. One right below it here. Is it linear or non-linear? Exactly, it should be linear. Proportional or non-proportional? It goes through 0, 0, so it is proportional. Excellent. See how easy this is? Okay, you get to try something like this. See you back in a minute. Okay, welcome back. Hopefully you paused the video and did your questions. Let's continue. Nonlinear equations are always non-proportional. We just said that. Okay, this is an example of a nonlinear equation. 6x squared plus 11x minus 35. This is called the quadratic equation. Hopefully we're going to do a little bit with this towards the end of the year. Quadratic equations are nonlinear and they are non-proportional. All linear equations will have an x-coordinate, get the dot out of there. We'll have an x-coordinate, a y-coordinate, a slope, and a y-intercept. This is the format for linear equations. This is the format for quadratics. A little out of order there. That one says it has an x squared. I already talked about that. Okay. Remember that y equals mx plus b equation can take different formats. We talked about this in a previous lesson. It can be the ax plus by equals c format. It can be in the y minus y1 equals m times x minus x1 format. But if they are in these other formats, it is still a linear equation. It's just in a different format. It's just algebraically rearranged. Linear equations can be proportional or non-proportional. So y equals 3x, is that proportional or non-proportional? Well, that's proportional. Why? Because it does not have a b. b is actually 0, so they don't show it. This linear equation does not have a b because the y-intercept is at the point 0, 0. Here is a non-proportional equation, y equals 3x plus 10. Because it has a b, the y-intercept is not at 0, 0. The y-intercept is at 10. So this is a non-proportional linear equation. Okay, let's try some. This equation, 3x squared minus 10x plus 2, linear or nonlinear? I hope you said nonlinear because it's got an x squared in it. Is it proportional or non-proportional? Well, it should be non-proportional because if it's not linear, it's automatically not proportional. Here we go. Try another one here. Y equals 1/4 x, linear or nonlinear? I hope you said linear. Proportional or non-proportional? Does it have a b? No. So that way it is proportional. If it doesn't have a b, it's proportional. No b. How about y equals 3x plus 12, linear or nonlinear? I hope you said linear. Proportional or non-proportional? I hope you said non-proportional. Why? Because it has a 12, it has a b. It's 12 units up from the origin. It's a shifted graph. Okay, how about this one? 3x plus 2y equals 8. Linear or non-linear? Well, this is one of these equations that is not in slope-intercept format, but it is in standard form. But it doesn't have an x squared, right? It's got a y, it's got an x, and it's got some numbers. It is considered linear. It could be rewritten into the other format if need be. Is it proportional or non-proportional? This one's a little harder to tell. This one is non-proportional. The way you would find that one out is you'd have to rearrange it algebraically to get y on one side by itself. This equation would result in y equals, let me think about this. Sorry about that beeping sound. 8, so you can do 2y equals 8 minus 3x, and then you're going to divide by 2y to both sides, and you're going to get y equals negative 3/2 x plus 4. So this is the same equation rewritten in slope-intercept format. We're going to do more about that later. You don't have to know how to do that right now, but just know that that is the same equation written in the common form that you're used to. So we know it's non-proportional because it has a 4, a b. Okie dokie. B is equal to 4, and I just kind of showed you that. Okay, how about this equation? Y minus 3 equals 1/5 x minus 2. It's got an x, it's got a y, it's got an m. It is a linear equation. It's in the point slope format. This one was in the standard format. This one's in the point slope format. This could also be rearranged to be y equals mx plus b format, the slope-intercept format. Algebraically, we could do that. Now you have to decide, is it proportional or non-proportional? Well, you'd have to do a little more algebra to figure this out. It is non-proportional. Maybe show you that a little bit later in the unit. The b in this case is 13/5. Okay? The number of years since Keith graduated from middle school can be represented by the equation y equals a minus 14, where y is the number of years and a is his age. Instead of an x, there's an a. That's okay. Okay? Is the relationship between the number of years since Keith graduated and his age linear or nonlinear? Proportional or non-proportional? So the A is taking the place of the X. That doesn't matter. There's still one variable there for that. So this would be considered linear. The equation is in the form y equals mx plus b with a being used as the variable instead of x. Therefore, the equation is linear. All right, now what about proportional or non-proportional? Well, it has a b, right? Negative 14 is the y-intercept. So it's shifted from the origin, so it is non-proportional. But the value of m is 1 because you can always put a coefficient of 1 in front of a variable. The slope of this line is equal to 1. And then the value of b is negative 14. Since there is a b, a y-intercept of negative 14, the equation is non-proportional. Okay, so you can look at actual word problems and figure out if they're linear or non, if they're proportional or non. You can also prove the relationship is non-proportional because in order to be proportional, y divided by x must be constant for all values of x and y. If we plug 16 in the equation for a, Keith's age y will be 2. Y over x is equal to 2 over 16, which is equivalent of 1/8. If we plug 21 into the equation for a, Keith's age will be 7. 21 minus 14 is 7. Y over x is 7 over 21. We reduce that down to 1/3. Notice how 1/8 and 1/3 are not the same number. Y over x is not the same. That's another way to tell that this relationship is non-proportional. Okay, so you can use different tests. You pick the one that you like the best. Are these linear equations proportional or non-proportional? S equals 25R, proportional or non-proportional? Different letters, they're not Y and X, but does that matter? Nope. It's proportional. There is no B. There's no y-intercept. Well, there is. It's 0, 0, but it's not shown in an equation. How about t equals 3.4k plus 133? That is non-proportional because it has a b. It has a y-intercept different from 0, 0. How about 48 equals 15d? 48 equals 15d. What about that? That's non-proportional. There's only one variable. Did you notice that? All the others have two variables. This one up here has an S and an R. This one has a T and a K. So you need to have two variables to have a linear equation. This one only, and to have a proportional equation. This only has a letter D, so that is non-proportional. How about C equals 512 minus 2n? That is non-proportional. Why? Even though it's in a different order, 512 is your B. That means that it is non-proportional if it has a B. It has a number other than 0, 0 is your center point. Negative 2n is the slope. Okay, I just wanted you to see that you can use other letters and you can still be using the same y equals mx plus b type equation. Okay, you get to try these. See you back in a moment. Okay, welcome back. Let's talk about distinguishing between proportional and non-proportional tables. Tables that do not have a constant rate of change are nonlinear and non-proportional. That would be your graph that changes, right? Your slope is your change. So a graph that's going like this has a different changing slope all the time, right? So that kind of graph, if seen in a table, is not a constant rate. So it is non-proportional, nonlinear. Let's look at that. Here's an example. You have y and x. This is just in a different format. Instead of going horizontal, the x and the y are going vertical. So this little triangle means the change in y over the change in x, which is your y2 minus y1. That's the change in y. The change in x is x2 minus x1. Just wanted you to see that format. So the change in y here goes from 3 to 2. It's going down 1, so negative 1. The change in x here is going from negative 3 to 1. That's a change of 4 units. So negative 1 is your change in y. 4 is your change in x. Let's go to the next set of points. Change in y over change in x. From 2 to 1, it's a change of negative 1. And from 1 to 7, it's a change of positive, or it should be negative 6. No, positive 6, it's going up. Okay, so then y is negative 1, x is 6. That is not the same, are they? Negative 1/4 is not the same as negative 1/6. The rate of change is not constant. That is a non-linear table. The relationship is nonlinear and automatically not proportional. Remember, if it's not linear, it's not proportional, since it is not linear. If you do the linear test by checking for a constant slope, rate of change, and that rate is not constant, you do not have to do any test to determine if it is not proportional. Nonlinear means non-proportional too. So if you get this situation, you can stop testing. You don't have to test anything else. You know it's nonlinear, you know it's non-proportional. Tables that have a constant rate of change are linear. If the ratio of y over x is constant, the relationship is proportional. If the ratio of y over x is not constant, the table relationship is non-proportional. So let's see the next page for something like that. Okay, this was the table we just did. We decided that one was not constant, nonlinear, non-proportional. Okay, now let's look at the other kind. Here's another table at the bottom left here. So the change in y over the change in x, let's see what that is. So we go from 1690 to 3315, that's an increase of 1625, that's your change in y. Your change in x goes from 130 to 255, that's an increase of 125. So the change in y is 1625, the change in x is 125. Divide that out with your calculator and you get 13. Okay, let's check the next set of points. So we go from 3315 to 6565. That's a change of 3,250. The x changes in amount of adding 250. So your change in y is 3250. Your change in x is 250. That's your slope. Your slope is 13 again. So you have a constant rate of change, a constant slope. So that means it must be linear, right? Because remember, this kind of thing does not have a constant slope, it changes. Whereas a slope with a line has a constant increase or decrease, constant, okay? The relationship is linear because the rate of change, the slope, is constant. So far, so good. Tables are the hardest. Okay, now we have to check y divided by x. That's to check for if it's proportional or not. So far, we just checked to see if the table was linear. Now let's check and see if it's proportional. Just y over x, not the change in y over the change in x, not the slope, y divided by x. Let's test these. So we have 1690 over 130 based on the table. Use our calculator, that comes out to 13. Do it again for the next set of points. 3315 divided by 255, that comes out to 13. And finally, do 65 over 65 divided by 505, and that gives us 13. Okay, they're all the same number. So that means that the relationship is proportional because y over x is constant. So if you have a proportional relationship, your slope is going to be the same as your y over x, but only if you have a proportional relationship. The reason why that works is, let's say you had a graph, and if it was proportional, it would go through 0, 0, right? So we can maybe go through right here, 0, 0. And if it does, if you try to do your, and let's say this point over here was 3, I don't know, 5, something that looks like about 3, 5. So then if you were to do your y2 minus y1 over x2 minus x1, you're changing y over you're changing x, you would get 5 minus 0 because your other point would be 0, 0 that you could use, right? And on the bottom you would have 3 minus 0. Well, what is 5 minus 0 over 3 minus 0? It's just 5 over 3. So notice how with a proportional relationship, you're getting y over x is going to be the same as your change in y over your change in x. Hopefully that makes sense to you. Okay, let's keep going. So this table is linear and proportional. Okay, this was the first table we looked at. We decided that one was not linear and that one was not proportional. Then we didn't have to do any more tests once we found out it was not linear. Okay, then we did one that had a constant, it was linear and it was proportional. Oh, this is a different one now, never mind. So this one, let's do the change in y, 30 to 90, that's a positive 60, and then the change in x is 2 to 8, that's a positive 6. So 60 over 6 equals 10. Do it to the next set of points. Change in y from 90 to 150 is another 60. And then the change in x from 8 to 14 is another 6. So that's 60 over 6. That equals 10. So this means this was our change in y over change in x. This is the slope. The slope is constant, so it must be a linear equation. So it's a linear table. The slope is the same. Now we have to check for proportionality. We use the different formula. We use y divided by x. So we take each point and we divide it. So 30 divided by 2 is the first point. That gives us 15. 90 divided by 8 is the second point. That gives us 11.25. And then 150 divided by 14 gives us 10.7. Notice those numbers are not the same. So we have a non-proportional situation. So when y over x is not constant, we have a non-proportional situation. So this table is linear, but it's non-proportional. If it was written in an equation format, it would have a b. If it was written in a graph format, it would not be at 0, 0. Okay, summary of the types of tables. Okay, that one was nonlinear and non-proportional. So the rate of change to the slope was not constant. If the table is not linear, it's automatically not proportional. You don't have to do any more tests. Nonlinear, non-proportional. Second table. Change in y over change in x was 13. The rate of change, the slope was constant, so that means it's linear. And then we did y divided by x. That was also 13, so that means it was constant rate ratio. So that was proportional. So linear and proportional. And then the third table we looked at, we decided the change in y over the change in x was 10 every time. The rate of change was constant, so it's linear. Y over x, however, was not constant. It changed. So the ratio was not constant. So it was linear but not proportional. Okay? Go back and look at these slides later so you understand what you're doing, okay? Okay, let's look at this table. Linear or nonlinear? Proportional or non-proportional? Okay, so we have to check our change in y over our change in x for each point, right? In order to decide if it's the same or not the same. So it turns out to be nonlinear. So I guess we could do a couple, let's see. So if we did 4 minus 1, that's 3. And negative 2, this is the plus 3, right? No, it went down. And this one went from negative 2 to 1, so that's a positive 3. Okay, that change. This one went from 1 to negative 1. That's a change of 2 going negative. And this side went from 1 to 0. That's a negative 1. Notice how already we see that the slope is not constant. So that's why we know it's nonlinear. The slope is not constant. Okay, is it proportional or not proportional? Well, what we already know, if it's not linear, you don't have to do any more tests, it's non-proportional. Okay? Nonlinear, then always non-proportional. The two nons go together, non and non. Non-linear, non-proportional. Okay, next table. Linear or not linear or non-linear? Let's check. From 1 to 8, the change is a positive 7. From 5 to 40, the change is a positive 35. So the change in y over the change in x is 7 over 35. That's the slope for the first one. Let's check the next one. 8 to 13 is a positive 5. This change is 25, positive. So this one has change in y is 5, change in x is 25. Next one, 13 to 16, plus 3. From 65 to 80, 15. So this is 3 over 15. What do you know now? That's not right. That's nonlinear. The change in y over the change in x is changing. The slope is not constant, so ignore that one. That is incorrect. And then it's automatically non-proportional, but this is going to say proportional, but it isn't. So ignore that one. Let's clear that. Let's go on to the last one. I believe there's one more. Hopefully this one's right. X this one out. I'll fix it before I post it. Okay. We have to check our change in y over change in x. That's a plus 15. What is this going from? 25, 35, 45. That's 20. So this is 15 over 20. 15 over 20. This goes from 30 to 45. That's 15. This goes from 45 to 65. That's 20. So that's 15 over 20. And then the final one, 45 to 60 is 15. And 65 to 85 is 20. So we can tell that this is going to have a constant rate of change. So this one actually really truly is linear. So yes, it's linear. Now we have to check to see if it is proportional or not. So again, when we check proportionality, let's just see, it's going to bring up our line first. Proportional or non-proportional? Slope was constant. Now is it proportional or non-proportional? Well, now we're checking for, let me just erase this x here. Okay, now we can say y divided by x. So y is 15, put it down here. X is 25. in the first point. The next point is 30 and 45, and we have to reduce that and see if that's the same number, right? And then we have 45 and 65. And then finally we have 60 and 85. Now if we were to reduce these, and use my calculator here, 15 and 25 is 3/5. That one's easy, I don't have to use my calculator for that one. So this reduces down to 3/5. So we have to see if the other one's reduced down to 3/5. If not, it's non-proportional. So if we divide 30 and 45 by 15, I believe 45 divides by 15 3 times. So 45 divided by 15 is 3. 30 divided by 15 is 2. I can already stop. Why? Because 2/3 is not equal to 3/5. So I know that it is going to be non-proportional. So it is linear, but it's non-proportional. Let's clear all this away, and it should pop up that way for me. Non-proportional. So table 2 in the middle here, I'll just fix that on the slides so you can take a look at that on the slides. All right, let's move on. Your turn, number 3. You get to try tables. See you back in a moment. Okay, welcome back. Let's compare proportional and non-proportional situations. A laser tag league has the choice of 2 arenas for a tournament. In both cases, X is the number of hours and Y is the total charge. So the more hours they rent it, the more it's going to cost them. Compare these two situations. Arena A, Y equals 225X. Arena B is a graph. So Arena A is an equation. Arena B is a graph. Let's compare. Okay, the hourly rate is your slope. So if you want to go to Arena A, you're going to pay $225 an hour to do laser tag. Okay, for 1 hour, $225. For 2 hours, it would be $450. Okay. The entrance fee is 0. Why? Because there's no B. There's no entrance fee. Okay, let's look at the graph for Arena B. It's at 0.50. Okay. So it starts at 50. It doesn't start at 0. So there is an entrance fee. And then we'll pick another point on the line, and we're going to find the slope. The slope is rise over run. We're going to rise negative 200, and we're going to run negative 1. Negative 200 over negative 1 is a rate of $200. So it costs $200 an hour to rent Arena B. So it's a little cheaper that way, but because this starts at 0.50, they're charging a $50 entrance fee one time. So the y-intercept entrance fee is $50. So which is your better deal? This is the equation for this graph. Y equals 200x plus 50. There's your $50 entrance fee and your $200 an hour rate. Arena A has a higher hourly rate, but no entrance fee. Arena A is proportional because B, the y-intercept, is 0. Arena B has a lower hourly rate, $200, but has a $50 entrance fee. Arena B is non-proportional because B, the y-intercept, is 50. Jessica is remodeling and has the choice of 2 painters. In both cases, X is the number of hours and Y is the total charge. Compare the two situations. So if Jessica has the painter work more hours, she's going to pay more money to the painters. Painter A's equation is Y equals 45X. All right, what can you tell me about that? Painter A charges $45 an hour. Okay. Painter B, here's a table for Painter B. What can you tell me about that? Well, you have a point 0, so when x equals 0 and y is not 0, that's your y-intercept. So painter B has some $20 fee just before he even starts painting, right? Okay, let's figure out. That's your hourly rate for painter A. Your y-intercept was 0. Okay, we're going to have to pick 2 points on this table and do y2 minus y1 over x2 minus x1. So I chose these first 2 points. So I did 55 minus 20. This is the same as the other one, which was going up and down. Now we're going back to left and right. 55 minus 20 and 1 minus 0. Do the math for that, you get 35. So that is the hourly rate for painter B. And the y-intercept is where x equals 0. So he charges an initial fee of $20. So his equation is y equals 35x plus 20. That's his hourly rate. 20 is your y-intercept. Painter A has a higher hourly rate, but no initial fee. Painter A is proportional because B, the y-intercept, is 0. Painter B has a lower hourly rate, only $35, but he or she is charging a $20 initial fee. Painter B is non-proportional because B, the y-intercept, is 20. So what that might mean to me is, if I was going to have the guy, painter B, for just 1 hour, 35, 45, that would cost me $55. If I was going to have painter A for just 1 hour, that would only charge me $45. So I would go with painter A. However, if I wanted to hire them for 2 hours, I would pay how much for painter B? 35 times 2, $70 plus 20. I would pay $90 for 2 hours with painter B. How much would I pay for painter A? I would pay $90 for painter A. I would do 45 times 2 hours. So then it wouldn't make any difference, right? Then it would be, either one would be fine. However, what if I wanted to have them for 3 hours? Then we plug in a 3. So 45 times 3 is $135 for painter A. If I was to plug in 3 over here, I would take 35 times 3 plus 20 more dollars. It would cost me $125 for painter B. So at this point, after I get past 2 hours, if I have to hire somebody for more than 2 hours, painter B becomes the better deal. So you can see how using these equations can really help you when you're trying to figure things out in real life. So maybe one day you're going to hire a painter and you're going to make equations to figure out which is the best painter to hire. Okay, anyways, now it's your turn to try one of these. Okay, welcome back. We are done. We are on Google Classroom lesson 4.4, and I will see you guys in your next lesson. Bye.